So where we left it last time was we have load accumulator is all been implemented and it's got unit tests. LDX and LDY haven't been implemented, but they do have unit tests, and I can run them by running this. And there's all the tests that were in, and they are currently all failing because they have not been implemented. So the job today is to implement LDX and LDY. So all these different addressing modes, not as many as LDA, but there's still quite a few. And I want to do it without rewriting lots of code, because most of the code is going to be the same. Because LDA, if you look up here, has a zero page and a zero page X, and LDY also has zero page and zero page X. So a lot of the code is going to be the same. So we should probably start with just LDX. Let's start with LDX Immediate, maybe. So we should probably start with immediate mode, because immediate mode is just where the value to be loaded into the register is just the next 8-byte value in memory. And you can see it here, LDY Immediate, it just fetches a byte from the program and just stores it in the A register, and then sets the status flags. I think the status flag setting is exactly the same in LDX and LDY. Yeah. So we should probably, first thing we should do is rename this to load register set status, because that's what it actually does now. It's just, yeah. So that's sets the processor status flags after a load register. So that's the first thing. I didn't really change anything, but just names it better. I think for LDY Immediate, because it's so simple, maybe what we'll do is we'll simplify this a bit. So that just loads a byte straight into the A register. And then Immediate, yeah, Immediate is so simple that it's just really the same bit of code twice. So that's LDX Immediate, and loads into the X register. And LDY Immediate loads into the Y register. So those ones are quite trivial. So there's not really much duplicated code there. We're just calling the same two functions. So I think that one's good enough for that one. So LDX Immediate can load a value into the X register. That has failed though. So why has that failed? Oh, that's interesting. Is that definitely... Yeah, so already we've fallen over a bit. What's gone wrong with that? It's got the wrong flags. Have I messed up with the flags? That's odd. Let's breakpoint in here and see what's going on. So we are going to do LDX Immediate, which is A2, that's the correct opcode. So it should be loading 84. Use 2 cycles and it should be loading 84 into this CPU, which it does. Expects 2 cycles used, and expects CPU Z to be false, which it's not, and negative flag to all to be true. So is this just a bad test? What's going on here? Why is this why does this pass on the A register test then, but it doesn't pass on this one? Let me just go back and have a look at the A version of this, because this A version should do the same thing. Goes in and we get 84 out, we do, except that's getting different status flags. What? That doesn't seem right. Interesting. Already we've fallen over here a little bit. So let's look at the X one. So it should be Fetching the byte is the immediate mode. Fetches the byte into the X register, and then we set the status registers. Oh, there's the problem. It's testing the A register. So this needs to pass in. This needs to actually pass in the address of the register to test. Whoops. In fact, we don't need to pass that in by reference. We can just pass that in. Yeah, because it's literally just a byte. I'm not passing that as it's a byte, an 8-bit number, and I'm passing it as a 64-bit address. That's ridiculous. Excellent. So, right, okay. So in theory now, what's different now is, I said this first test was easy and already it wasn't. So we have to pass in the address of the register that we want to, or we have to just pass in the value in the register. Passes in X and that passes in Y. Oh, it's just Y. Because we are the CPU at this point. Right, nearly there. So I said the first one was going to be easy. Oh, and now I've got to go through and I've got to fix up all these ones from the A register. So initially, a first bit of refactoring already went a bit weird. And that's interesting as well. These ones don't seem to be setting LDY Absolute X, Absolute Y, Indirect X. They don't appear to be setting the registers either. So that means we didn't have any tests for those, maybe. Or maybe the tests weren't good enough to catch that. So let's just make a note of that. One there, one there. Oh, and we don't need it on JSR because that's different. Oops, didn't want that. Okay, so yeah, so it looks like the LDX tests have now passed. LDX Zero Page can load a value into the A register, the X register. Oh, it's LDX Immediate that we just did, isn't it? LDX Immediate, LDX Immediate, LDY Immediate have passed. So have we got 10 failing tests? Yeah, so we just made 2 tests pass. So that's good. That's a good start, except my problem now is I feel like some of these other tests are not complete because they're not testing the processor status correctly. Maybe because the tests aren't good enough to do that. Let's have a look. Yeah, so this one, because it's expecting false and false, and we didn't set them, but they were already set to false and false. So maybe what I should do is at the start of this test, I'm going to set the Z flag and the negative flag to the opposite of what they should be, and they should definitely get changed. See, that shouldn't change the test. No matter what those flags were before, they should get set afterwards here. So this is a case of where I'm not going to go in and fix the code straight away. I'm just trying to make 11 tests fail. I'm just trying to make more tests fail so that I can fix them correctly. So which one has failed there? LDY Absolute can load a value into the A register. So that has failed. What were the other ones? LDY Absolute X. So we'll just change these tests a bit to make, yeah, so let's make them do the opposite of just make the CPU in a state that should get changed. So in the end, I fixed one test, and I'm going to make more fail. I mean, I've got 12 failed tests. LDY Absolute Y. Second this one again. So these weren't very tested. The tests are now. So that's the next one. 13 failed tests. It's getting worse. The program's getting worse. LDY Indirect X. 14 failed tests. Oh, this is crazy. It's the same bit of code again on that one. 15 failed tests. And JSR, we're not dealing with that yet. So we are back to having our failed tests again. Now we can just make these tests pass. So that's one important thing to do with unit testing is that you get a problem, and what you really do is you don't fix it immediately. You write a test that you make sure that the test fails. Otherwise, you've not written very good tests. Because I'm going to reuse these tests, or I'm already reusing these tests for the LDX ones and stuff. So by making the test better, I can make the rest of the code better that I write as well. So I can get this back to 10 tests failing by implementing the I think I just got to implement this on all these A register versions. And let's give that a proper title. This is sets the correct processor status after our load register instruction. We'll just put LDY LDX LDY. So now we should be back to 10, is it? Yeah, so we're back to 10 again. Cool. So we've improved the tests, and we know this stuff's working now. Right. So back to the problem at hand. So we've got we've got LDX Zero Page and LDY Zero Page. So these are the ones that we probably want to where we probably want to start refactoring some code, maybe, and we can refactor this stuff into basically into we want to refactor this into so the addressing mode is out on its own, because we're going to reuse the addressing mode in lots of different places. So in this instance, it's how do we get an instruction that gives us the effective address, basically. Yeah, basically I need a function that can give me the effective address that I need to read the value from, regardless of the addressing mode. At the end of the day, this is all these do. Like LDY Zero Page basically gives me a zero page address, and LDX Zero Page X basically at the end of the day gives me a zero page address. So that's the kind of thing we want. So what I want to do is take out, I know it's only one function, but we just want to take out the addressing part of this, because we're going to keep reusing that, and then we know what's right and what's wrong. So let's do that. So we'll call this Zero Page. Let's start them on with addressing mode. Something like that. And these return a byte because it happens to be, I mean, we could return a word really. Yeah, we might as well return a word from this. Because we want to return the address of somewhere in the zero page, which is technically a byte, but it's an address, so an address is always a word. It's 00 and then the address in there. So I think this is the way to go here. So in effect it becomes this, and it needs to take in the is it S32 cycles, and it wants the memory. Did I just call it mem? And that'll get promoted up to a word on the way out, hopefully. We can check that though. So I think that's correct. So this is zero page addressing. Right, I think that's right. So we just call that in place of this. Which really, in this case of this one, it's just really just renamed the function. That's really kind of all it's done. There we go. So we've just kind of refactored zero page addressing there. And we'll just call all our addressing modes. We'll start them all with that ADDR. Let's just check that that still works. We've still got 10 failed tests, which is what we had before. And now we want LDX Zero Page, which reads a byte and puts it in the X register and sets the register status from the X. Should have 9 failing tests. Yep. And we can do the same thing with Zero Page Y. Or LDY Zero Page, sorry. Which is, that puts that in the Y register and it sets the status from the Y register. So we're refactoring all the addressing modes. That's what we're doing now. So that one's become addressing mode zero page. It makes it, it's going to make life a lot easier when we come to do all these instructions, because we don't have to think about how it works. We just know, oh, it's zero page addressing. We just call that and it knows. At the end of the day, these are all just going to come out with an address for us. That's all they're going to do. 8 failing tests. Cool. So we've got a little bit further. So we've now got zero page X. So it's zero page with an X offset, and only LDY does that. So again, we want to do, we want to take this part of the function and we want to extract that out into a zero page X addressing mode. So let's do that. We'll kind of copy this one because they're all going to be very similar. And where are we? It's basically this. I think it's pretty much, actually it's just exactly the same, except it's exactly the same as the first one, except we just add the X and take a cycle off as well. Got enough room to put this on in one line. I think that's right. So we just use that in place down here. So in fact we can just do, take that, so all these functions now just give us back an address. So they all kind of starting to look quite similar. See what I mean? We're just calling a different addressing mode. which I suppose under the hood is kind of what the processor would be doing. It would be saying, oh, this addressing mode is this bit of hardware, and that's how we read it. So nothing should change there. We're still on 8, except now it's a lot less code to refactor LDY Zero Page X. Is that the one? Yeah. And that loads into the Y register and it sets the status from the Y register. 7 failing tests, we're getting there. Cool. What's the next one? Absolute. Let's do Absolute next because it's the next one on the list. So let's do this. So again, we just want a function for absolute addressing mode that just takes in the cycles in the memory and then just gives us back the address to read from. This is absolute. Let's call it absolute. And this one, again, I'm going to take the... Oh, it just fetches a word. That's really all that one does. Wow, so we just kind of, at the moment, this just ends up being... Yeah, ends up being quite similar again. You can see all this, like this, how this code's quite similar-ish. But at least if you've got functions for it, we might want to inline these very simple functions as well, actually, because they're going to be so simple. There we go. Addressing mode absolute. Keep going back to the wrong place. Where are we? In my giant switch statement. So we just swap this out for so again, that changes nothing really. Should still have, is it 7 or 8? 7. But now we can do LDX Absolute, which reads into the X register, sets the status from the X register. Six failed tests. Hey, look at this. And same thing for the Y. Reads into the Y register, sets the status for the Y register. Boom, 5 failed tests. Cool. So LDA Absolute X. So this one needs to be factored out, I believe. So this one's actually reading the byte in the middle. We should do that down there. And that makes more sense because this is kind of the addressing mode then. So let's take this part. And this is absolute with an X offset. That's right. And it returns the, which is the address that it actually returns, this one. So we just swap that code out now. Yes, the addressing mode is now just factored out into its own function. And we get rid of that. So these are all starting to look more uniform now, these giant switch instructions. So LDA, so I think there's an LDY Absolute X. There is an LDY Absolute X. Which reads into the Y register. So there's still a lot of code kind of repeating, but at least we're repeating just a few simple, like we're getting 3 lines of code down for these load register instructions. How many have we got now? We've got 4 failed tests. So LDY Absolute Y, again, same thing here. This kind of read byte is kind of down here. In fact, that's how the processor would have done it as well, because this extra cycle that it has to calculate from this addition that's doing would have been done before it read the address. So this makes more sense. So we'll take that, we'll stick that in there. And this is the same thing, except it's absolute Y. That still compiles. Let's just go and, oh, that's the wrong place. Let's go and find our absolute Y addressing. So this gets replaced now with that. And again, nothing should change there. Oh, what's wrong? It's not returning a value. So something did change. That's the one we want. Yeah, so still got 4 failing tests. So that's absolutely just nothing's changed. That's what we wanted. And now we can do LDX Absolute Y just by changing that, changing the value it reads into, and changing the value of that. 2 failed tests. Cool. So what's left? What is left that we've not done? Zero Page Y. LDX Zero Page Y. And LDY Absolute X. LDX Zero Page Y. Why is that not? Oh, because I haven't done Zero Page Y yet. Where's that? Oh, is that a new instruction? Zero Page X. Oh, because there is no Zero Page Y. Wait a minute. No, I'm looking at the wrong thing. Zero Page Y. Was that something that didn't... Oh, that was something that didn't exist on LDA. Ah, there we go. LDA does not have a Zero Page Y addressing mode. So that's a new addressing mode. Oh, that's interesting. I didn't think that was going to happen. So let's write that. So that should be the same as the X addressing mode. Is that right? Yeah, 4 cycles. This is going to be the same as the X addressing mode, except it's using the Y register. So this is a new piece of code. Didn't realize that. It's different, slightly different. Zero page with Y offset. And yeah, and LDX can do that. Wait a minute, where is this instruction? Oh, we haven't written it yet. I'm looking for an instruction we haven't written yet. So this is brand new. Yeah, let me just check that. LDX Zero Page Y. Let's just put it next to this one. LDX Zero Page Y. The addressing mode is Zero Page Y, and it loads into the X register again. So that should fix that. Yep, so we've got 1 left. LDY Absolute X. Now we did have an Absolute X, didn't we? Yeah, we've done that on LDA before, so we do have that one. Absolute X, there it is. Oh, we've already done this one. We've already done addressing mode Absolute X on LDA, so we need, I've already forgotten, LDY Absolute X. Is that right? Looks like we've already got it there. LDY Absolute X. We've already got this instruction here. That seems odd. this test named wrong? It's LDY Absolute Y can load a value. LDY Absolute, no, it's LDY Absolute X can load a value into the Y register. What's wrong with this test? LDY Absolute X, so we definitely implemented that one. LDY Absolute X. Yeah, apparently this isn't working. Because you're doing it as absolute Y, not absolute X. The test is wrong. That's an invalid test. That's what's going on there. Already, I didn't need to debug it. It's just so LDY Absolute X. And there we go. We're done. So we've implemented quite quickly, actually, the new addressing modes for, well, we've implemented LDY and LDX completely, and we've implemented one new addressing mode. And to do that, we've just put these, we've just got these new functions in down here. I'll move these to the bottom of the CPP file because you're not going to look at these. Once these are done, you're going to be more interested in this execute function. It's better to have the code you're working on more often at the top. So yeah, we definitely didn't, we definitely left some of the LDA instructions untouched. We didn't refactor them, but we've definitely got more addressing modes that have been refactored out now. So that's really good. So that is LDX and LDY done. In fact, that's all the load register methods done. So next we can move on to something new. Maybe we do the opposite ones, the store. Let's have a look. Yeah, because we've also got store accumulator, store X register, store Y register. These should be a lot easier to write now because we've done all these addressing modes already. We're just kind of doing the opposite thing now. We're doing it in reverse. We're taking the value out of memory and putting it in the register. Taking the value out of the register and putting it in memory, sorry, rather than the opposite way around. So these might be the next ones to get through because we've already got a lot of the code to do those. And we've already got the unit tests kind of refactored to get that going. So that's really good. I'm quite happy with that. That is 10 new instructions working. So we'll see how far we get. I think this, I can't remember now, is it like 150 instructions? I've done 18 out of 150. So, but you can see it's getting a lot quicker now because I'm just reusing code all over the place. So this is really cool. So next video, we'll probably do the store, store register values as well.